Now, what we're going to do today is we're going to change a decimal number into a binary number, which is the opposite of yesterday. Remember yesterday you started with a binary number, you drew your place table for the binary number, and then you turned it into a decimal number. Now, first up, the reason you should know that 109 is a decimal number is because not all of its digits are 0 and 1. You'll notice here we've got a 9. For any number to be binary, it can only contain ones and zeros. So that's how you know straight away that this is a decimal number. And we want to change it into a binary number. Now, the setup is similar to before in that you're going to draw a place table for the binary number that we want to get, that we want to find. We want to work out what is 109 as a binary number. So we're going to draw our place table. Remember, it has 2 rows. Okay, our top row is always called the place name. And then our bottom row is our place value. Now, we're going to go right to the very last column here. Okay, very last column. And we're going to start with the place name. So the very last column, the place name is called the units, otherwise known as the ones. And because our answer is going to be a binary number, these place names are all for a binary number. So remember, to get to the next place name for a binary number, you always multiply by 2 when you move from left to right. So we're going to multiply by 2. So the next place name is going to be the 2's. Multiply 1 by 2, you get 2. So the place name is the 2's. We're going to multiply by 2 again. And then that's going to give us the 4's. Going to multiply by 2 again. That's going to give us the 8's. Going to multiply by 2 again. That's going to give us the 16's. Multiply by 2 again. That's going to give us the 32's. Multiply by 2 again. That's going to give us the 64's. Now, if we multiply by 2 again, we're going to have 128. Now, 128 is bigger than 109. So you write all the place names out as far as the decimal number. So the place names can either be the same as the decimal number if it's possible, or less than. You can't have a place name that's bigger than the decimal number. So that's why we stop at 64. So we stop because it's the last place name before the decimal number. Now, what we do then is we have to decide whether we're putting a 1 or a 0 in the place value row, because remember, our answer is going to be a binary number. So each digit of the place value can only be a 1 or a 0. So in order to determine whether we put a 1 or a 0 in each place value here, we start with a decimal number. So we write the decimal number 109 down. We then go to the very first place name in our table, which is 64, and you ask yourself, is 64 less than or the same as 109? The answer is yes. So if it's a yes, you put 1 under it, and then you subtract 164 from the decimal number to get the remainder. So we're going to subtract one of those 64s. So that's going to leave us 9 minus 4 is 5, 10 minus 6 is 4. So we've now got a remainder of 45. So what we now do is we go to the next place name and we ask ourselves, is 32 less than or the same as 45? If the answer is yes, we're going to put a 1 underneath it. So it is. We put a 1 underneath it. And then we subtract one of these 32s from 45 to get the next remainder. So we subtract 32, and that's going to give us 5 minus 2 is 3, 4 minus 3 is going to give us 1. So we're now left with 13. So you go to the next place name and ask yourself, is 16 less than or the same as 13? The answer this time is no. 16 is actually bigger than 13. So when the answer is no, we're going to put a 0 in. What that basically means is that 16 doesn't fit into 13. It's too big. Okay, so we go to the next place name, which is the eighths, and again you ask yourself, is 8 less than or the same as 13? Well, it is. So we therefore put a 1 underneath it. And then what we do is we subtract one of these eighths from 13 to get the next remainder. So we're going to subtract 8. And then that's going to leave us with 5. So again, go to the next place name, which is the 4s, and ask yourself, is 4 less than or the same as 5? The answer is yes. So when it's yes, put a 1 underneath it. And then subtract this 1 4 from 5 to get the next remainder. So we're going to subtract one of the 4s, in other words 4. And that's just going to give us a remainder of 1. So again, go to the next place name, which is the 2s, and ask yourself, is 2 less than or the same as 1? Well, the answer here is clearly no. 2 is bigger, so we're going to put a 0 underneath it. There are no 2s that fit into 1. And then that just leaves the units column. So you ask yourself, is 1 less than or the same as 1? Well, the answer is yes, so you put a 1 under the units place name. And then we subtract one of those units from the remainder. So we subtract one of the units, i.e. 1, and then we're left with a remainder of 0. Once our remainder is 0, we then stop. Now, what we now do is we go to the place value table and we look at the bottom row, the place value row. So the place value row gives you all the digits that make up the binary number. So the binary number is 110101. So our answer is 1101101. In other words, that is the binary number which has the same meaning as 109 as a decimal number. So we've changed 109 as a decimal number into a binary number.